Hi guys, I'm going to be showing you a quick tutorial on how to transform sinusoidal waveforms into their polar and rectangular forms. So you'll be given the equation a sine omega t plus theta, and this is the sinusoidal waveform, where a is the amplitude and theta is the phase angle. So to put it in the polar form of z at the angle of theta, all you need to do to find z is put the amplitude over the root of 2. This will transform it into the RMS value we need, and the theta just comes straight from the sinusoidal equation. After you find this, you can use simple trigonometry to transform the polar form into the rectangular form. As you can see here, using SOHCAHTOA, y will equal z sine theta and x will equal z cos theta. That will convert from polar to rectangular. And converting from rectangular back to polar, all you need to do to find z is use Pythagoras' theorem, where z will equal x squared plus y squared under the square root, and theta will equal the inverse of tan y over x. So just to run through a quick example, we have the equation 10 sine omega t plus 35 degrees. To transform this into the polar form, all we need to do is put the amplitude over root 2 and have it at the angle of theta. This will be 10 over root 2 at the angle of 35 degrees, which will then equal 7.07 at 35 degrees. Next, transforming this into its rectangular form, all we need to do is go x equals z cos theta, which will then go to 7.07 cos 35, which will equal 5.79. And then to find y, we have the same equation but with sine, which will equal 7.07 sine 35, which will equal 4.06. And then to put it into its actual rectangular form, you have 5.79 plus j 4.06. And if you wanted to convert its rectangular form back into its polar form, you have z equals the square root of x squared plus y squared, which equals the square root of 5.79 squared plus 4.06 squared, which will equal 7.07, which is the same as what we had here. And theta will equal the inverse of tan y on x, which is the inverse of tan 4.06 on 5.79, which will equal 35 degrees, which is what we had there as well. Thank you.